how you like that? You gon' like that?
Assalamualaikum warahmatullahi wabarakatuh. Welcome to first semester in this grade. First meeting we will learn about antiderivative and indefinite integral. Maybe in the previous class we learned about derivative, right? So do you remember the formula of the derivative? I hope you still remember it. If f(x) is equal to x squared, so what is the first derivative of it? So we can get the 2 in here in front of the x squared, and then the formula in the power we must minus by 1, so we can get the 2x. And if we have the f(x) with x squared minus 1, so the derivative is still 2x. And then if we have f(x) with x squared plus 3, so the derivative is still 2x. Every number in here we can symbolize with c, because the c is a constant number. So if we have the f(x) is equal to x squared plus c, so the derivative is still 2x. So from the previous meeting we have the f(x), and in here I symbolize with the big letter of f(x). So we have the x squared minus 1 until the x squared plus 10. And then we have the derivative of the f(x) in here is f prime x, or f prime x in here we can symbolize with f(x) with f with use small letter. So the derivative is all of this table is 2x. So from the table we can see the general form of f(x) is equal to x squared plus c, with c is the constant. So every function from the differentiate have the f prime x is equal to f(x) is equal to 2x. From the table we have the f prime x is equal to f(x), right? So in here it is called the derivative from f(x) with the big letter. So the function of f(x) with the f(x) with using the big letter in here is called the antiderivative from f prime x is equal to f(x). What is the definition? So the definition let f(x) be a differentiable function such that f prime x is equal to f(x). So the f(x) is called the primitive or antiderivative of the function f(x). So in here f(x) is called the primitive of f(x), or we can say that it is antiderivative. And c in here is the constant of integration. It is integral sign. So if you want to solve the problem of integral, so you must use this sign. And then f(x) in here is called the integrand, and the x in here is called the differential. Let's see the table in the screen. You know that complete the following table with the correct answer. So from here we know that it is have the x squared until the x power of n, right? If we want to know the x squared and something like that, usually it is correlate with the derivative, right? So from here if we have the 1 over 2x squared, if we want to derivative this function, so we can get x, right? Because 2 over 2x power 2 minus 1 still 1. So it is we can get the x, right? So if we have the 1 over 3x power of 3, so the derivative is x squared, and so on, right? And if we have the f(x) and the integral of f(x) dx, for example, if we want to know the 2x squared, so we have the 2 over 3x power of 3. If we derivative this function with 2 times 3 over 3x power of 3 minus 1, right? So we can get 2x squared. If we have the form in here, if it is derivative, so we can get the 2x squared. So it is called the antiderivative. So from here, based on the pattern in the table, it can be concluded that if f(x) is derivative from the function f(x), we obtain that with the integrals of f(x) dx, and then for each f(x) is equal to x power of n, we obtain that with integrals of x power of n dx, And if we have the fx is equal to ax power of n, we obtain it with the integral of ax to power of n dx. Continue our lesson because we have know the definition of the integral. So in here we can see the basic integration formula. It is for make you easy to solve the problem about the integrals. In the integrals, we have the formula like this. If the integral of x power of n dx, so it is same with x power of n plus 1. So it is must plus by 1, and but it is must over with n plus 1. It is same with the power of it. So it is can take in here plus c. For n, any real number cannot be negative 1. So and if the integrals in the integrals we have only constant number a. It is not conclude the x, y, and something like that. So the integrals of it is ax plus c. So we can just put x in this result of the integral. Okay, let's see the examples. Let's see the activity table 1. If we have the integration of the fx is equal to x in here. With the basic integration formula, we get the x power of, it is power of 1, right? 1. But in the integral with plus by 1. So it is can plus by 1 over, because it is the power is 1, is we can fill in here, plus 1, because usually in this part and in this part is the same, always same. So we can get the x power of 2 over 2, or we can have the half times x squared plus c. Same with x squared, x power of 3, and so on. You can please do yourself in your notebook maybe. Let's see the activity table 2. For example, like this. If we have the integrals of 2 times square of x dx. If we know that the x is the square root, so it means that x is power of half, right? So it is no problem because the power is any real number, and then we can solve it. 2 is the constant number, right? So with the property we can change or put the 2 in front of out from the sign of integral, so we can only have the square root of x. With the square root of x is x power of 1 over 2, right? So 1 over 2 plus 1 is still 3 over 2, and we have the over in here, right? Because we want to know and it does not have the over, so we can get 2 over 3, or we can get the 4 over 3 x power of 3 over 2 plus c. You can try this and this and this in your notebook. Let's see the table 3 too. We have the integrals of x plus 3 dx. We know if we have the in here, so we have the integral of x dx plus integral of 3 dx, and the integrals of it, x it is have the power of 1, so 1 plus 1 is 2, and we have the over 2 in here because we can same with this power plus, and in this we have the 3. From the basic integration formula, if in the integrals only have the constant, so we can put 3 x plus here in here, so we can get this result. Okay, the next integration formula, we have the integral of 1 over x dx. You must remember that the integrals cannot negative 1, right? So if we have the integrals with negative 1, the integrals of 1 over x dx is can be learn the absolute x plus c. So all of the integration of 1 over x is learn absolute x plus c. And then if we have the integrals of in this part, it is derivative from this part, so we can get the learn absolute ux plus c. Let's see the example. This 1 over y. Because of in the previous, we know that 1 over x is ln x, so we can get this ln absolute y plus c. Don't forget to put 0 in here for all of the integrals, okay? And then integrals 2x over x squared plus dx. We know that 2x is derivative from x squared, right? So we can get with using the basic integration formula in this section. So we can get the ln ux, right? So from here we can get the ln absolute f x squared plus c, or we can get the ln x squared plus c. Basic integration formula for the next is Euler power of x. As the derivative before, a power of x, so the derivative is still Euler of x, right? So it is same with the integral. If we have the integral a power of x dx, so it is still a power of x plus c. And with the basic integration, the next is integral of a power of x dx, and a in here is only numbers, constant numbers, but we have the x as the power, so we can get the ax over ln a plus c. So it is basic integration formula. For example, like this, the integrals of 4a power of x dx. So the result of the integral is still the same, but we must put plus c in here, because a power of x is still a power of x. So there is no chance that with the integrals, but we must put plus c in here. And then for the next example, integrals of 5a power of x plus 1 dx. In here, a power of x plus 1 is still a times a power of x, right? And a in here is the constant because there is no x or variable, so we can put in front of the integral. So we can only have a power of x. A power of x with the basic integration formula is still a power of x, right? So but it is can plus by c, so it is can have the result. Basic integration formula for the next is trigonometry. Maybe in the derivative you still remember and still know the definition and the derivative of sinus, cosinus, and something like that. And in the basic integration formula, if we have the integral of sinus x dx, so the integral is minus cos x plus c. And if we have the sinus with the in the ax plus b in here, so the integrals is minus 1 over a in here, and sinus x plus b plus c, and something like that. And you can see in here, see the formula in the page 11 in the Jambak books. Please open it. And then for let's see the example. If we have the 4 sinus x dx, 4 we can change in front of the integrals, and the sinus, what is the integrals of the sinus? Sinus is minus cos x, so we can get the minus 4 cos x plus c. If we have the integral cos 7x plus 3, so with using the basic integration formula, we have the 1 over a. It is 1 over a is 7, so the integrals of cos is sinus, and it's still same plus c. So it is the all of the basic integration formula and indefinite integral you must learn. So I hope you understand for the explanation.
보란 듯이 무너졌어 바닥을